Honestly, I was expecting more people than this. So all of you at home have fun trying to figure this out just by watching the screencast. So hey everybody, welcome to, or you know what, probably what it is, they forgot where the classroom is. I come here every week and I kind of forget, it's like, is it the second floor, is it the third floor? Hi, welcome to week 6 of Advanced Programming with Java here at PSU. So let's see here, tonight, here's what you can expect. We'll start with the Prime Minister's questions. You can ask me questions about Project 4, which yes, is due Friday at noon, so everybody's got an extension because I want people here tonight. And then we'll do Android, and this will be different from what we've seen before. Because I didn't have the slides ready, I don't have a screencast for the slides. So tonight you get to see me lecture, but I'll go back and forth between lecturing and code, and we'll be able to have interactive discussions. So it'll be something a little different, and we'll try it and we'll see how it works. But to get started, what can I tell you? What questions do you have about? Let's start out with Project 4. Agent's thinking of something witty to say, or thought-provoking and insightful.
Not everything I say is sarcastic.
But you were thinking of something sarcastic to say. Okay.
I was told. Oh, this was not a good question, but someone said it's on the Slack channel. But so how do you run the Jetty server to specify a port other than 8080? Because like 8080 is the default, right?
Yep, there is a. Actually, I just did it.
Someone said it somewhere.
Do I still have it here? No, actually, I got it right here. I'll make it a little bigger so you can all see it. So I have, let's see here. I think that's, yeah. So if you say -D jetty.http.port equals whatever you want, that will start it. And you know it's running on that port because it prints out something that looks like this with the port number right there. So you're bound to localhost and on that port. So again, I was using run war, but you can just use jetty run. Yeah, that's the command that I use to grade your assignments. Essentially, I use a different port. But yep. So it's -D jetty.http.port. I can't remember if I think that's something that I use in my pom.xml. That's not a standard thing. I can't remember now. But yep, that's how you do it. Which is important when you're running on the PSU machines, right? Because someone else might be using 8080.
Yeah, I was trying to test it.
Shared machine, yeah. It's like, someone's already using it. Who is that? Yep.
So I have like a best practices question, I guess. As far as like the HTTP status codes go,
yeah.
If you have, so like on a website, typically in my experience, it's like if I give it input that's wrong, it doesn't give me a 404 error. It's like the website telling me something's wrong is part of like normal processes for the website. It's like the website's working if it caught my error and it's told me to like go back and do something different.
Yes.
So just because, like, even though like the logic in your code maybe throws an exception for like formatting, you wouldn't necessarily in all cases want to have that exception be met with setting a not acceptable status code if it's taking you to like the proper error message and like telling you to go fast.
Well, a REST API is not a website. They're not the same thing. Now they both use HTTP, but most REST APIs don't return HTML. Right? HTML is meant to, is a computer readable language that is for displaying stuff to humans. Where most REST APIs return something like XML or JSON, which is a barely, something a human can read, but it's really meant for machines to read. So, so similarly, I mean, if you want a website, if you want the experience of a human, you're right. I mean, it's been 20 years since you go to type in a URL and you get like the 404 page and it looks ugly. It makes no sense. Because a human, that's not good for a human, right? But back before the internet memes, no one knew what a 404 was, right? So you want to have a more friendly experience around bad stuff. Now, for your REST API, your API is an API. primarily it's meant to be consumed by a computer, and so a computer knows how to interpret a 404 or a 500 or a 401 or whatever, or a 300 move to a different edit, right? I mean, so they know about HTTP. Computers, programs know about HTTP, can handle those especially. So when you're building a REST API, part of the contract of the REST API is the error codes that it returns, the status codes that it returns, and then clients of that API can take appropriate action. Now, a common design pattern in web applications, especially modern ones that use things like asynchronous HTTP calls, AJAX, all that stuff that was popular 10 years ago, they call REST APIs, right? Because HTTP is already there. It has the ability to make an HTTP call asynchronously. And so it'll go off and call the REST API, and then it's your JavaScript code that's running in your browser that handles the result. And so it might know about the 404. It's, I got a 404. Okay, then pop up this dialog that says, please try again, or navigate off to a different resource, things like that. So again, I guess, a REST API is not the same as a web page because even though it's the same protocol, the same communication protocol, it's different data exchange formats, and you have different clients, different users.
Okay, so sorry, just to
Follow-up question?
Yeah, even if we were catching those bad statuses and having it print a message that's incompatible date format.
Yeah.
What would then be the difference of catching that exception, printing incompatible date format versus not messing with the status codes, but catching the exception and printing incompatible date format?
Well, the exception lives on the server side. So what are you going to do on the client side?
Just put everything in a try catch and catch the exception.
Well, again,
or print, have the exception on the server side, catch the exception, print to the page, where you
send it back.
You normally would have printed your appointment book information, print the error message, and then have the client side just get whatever's on the page.
You could probably get away with that for this simple assignment, right? Just have the call the REST API, and basically all the client does is take the results and spits it out. Now, one could argue, oh, wait, if you get an error, you should really write something to standard error as opposed to standard out, and so you kind of need to know if it's bad or good. So probably, here again, I'm not going to test that though, right? It's just whatever your program outputs. Right. So for a simple, for your first client server program, that's probably fine. But doing it for realsies and professionally, you want richness. You want the appropriate amount of richness in your API. And so then using the facilities that HTTP has for identifying data through the URL, conveying, moving data back and forth. So using something like XML or JSON, and then leveraging the rest of the stuff in the protocol, like the different verbs, like get and post and delete and put and all of that, plus the HTTP status codes, gives you a rich REST API. Nice.
So
any other questions?
I was just wondering because I was thinking of those errors and I was sending a message back to the client, but it didn't include different codes
That's probably fine. Hey, everything's a 404, right? Because you're not doing security checking. You're not doing. You look at some of those HTTP codes. What the hell does that mean, right? And so then gateway timeout, right? You're not going to leverage that. And I think in reality, in reality, I haven't seen that many REST APIs that go. That try really hard to leverage a whole wide variety of error codes because they're errors. They should be exceptional, right? So it's usually it's okay, if you can't find something, you get a 404. If your access is denied, you get a 401, 402, whatever. Right? There's a handful of them that you end up using. 500, is an internal server error or something. And even then, you might not want to expose those kind of details. It's just something to think about when you design your API.
Or you can get a 418.
A 418. What is 418?
I'm a teapot.
You're a teapot. Okay. What's the 420 error code? I don't know.
There's none.
There's not?
It goes
Whoa! It's gone, man.
It goes from 418 to
Sorry.
421. 418 is I'm a teapot, and 421 is Mr. Extra.
Wow.
Misspent youth. Okay. Sweet.
Right, HTTP don't have any sense of humor. It's pretty cool.
Well, it was the 90s. Okay, excellent. Other questions that I can answer for you? We'll talk about the final exam next time because it's the penultimate class. Yes.
Also, I do wonder,
like last week we had like survey or something, and then we have another survey that's due.
Yep.
I think that was project 5.
Yep.
What were those again?
They were surveys. No, it was. So it's another thing on D2L, which man, the surveys are always treated differently in D2L, so it's kind of hard for me to like. I guess they are on the calendar or something, which is dumb.
Yeah, doesn't get notified me.
Well, I did give everybody, which I think I said on Slack. I think I gave everybody a couple extra days to do it. Did I say that on Slack to everybody, or was that okay? I'm getting some nods there. It wasn't just a DM or something. So yeah,
Oh, okay.
your feedback is important to us.
Those are also upgraded.
Sorry, what?
Those are also upgraded or?
Yes, it's meant to be an easy 3 points, 4 points, if you do it. Send me a DM and I'll open it for a couple more days. Yeah.
So, say if like we missed our deadline though, we should.
Send me a DM and I'll open it up for so direct message me in Slack and I will open it back up for a couple of days. Yeah. Yep. Dave's the best professor ever. He gives us extra time to do stuff. Too bad like he doesn't tell us about the stuff he wants me to do. Yeah, I got it. Okay. Cool. Anything else?
So was the next survey you said was due on the last day of class?
Yeah, so there's like a midterm survey and then there's the end of the term survey.
It's like how our community changed since the midterm survey.
It's different questions on the end of the survey. It's a little bit more holistic. It's not just like the general tell me how I'm doing. It tries to get a little bit more information about it. Yeah. Okay. What else? Anything else on your mind? Seen a few more people than previously. Thank you for coming out tonight. I hope it'll be worth your while because tonight we're learning about Android. So unless there's anything else, let's dive into it. Okay. I covered this stuff last time. I started on the slide. So, okay, just to back up. I think I gave you the spiel last time about how I used to use a web framework called Google Web Toolkit, which you get to write in Java and write web applications, and it was kind of neat in a way, and it taught you lots of good stuff about UI development, but the framework is getting old and nobody uses it, and it's a little weird, so I decided, okay, we'll do something else that lets you write modern user interfaces in Java, and so I chose Android. I already used jokes like, have you heard of a cell phone? So I'll have to get some new jokes tonight, I guess. Right. So I've got the slide deck. The slide deck is still very much incomplete. I added a bunch of content in the last week, which rounds out a bunch of stuff, although I realized that I don't have anything in there about handling data, which will probably be important for your class. So tonight what we're going to focus on is a bunch of fundamentals, and then we're going to look at how to do like the UI part, and that'll probably be plenty for tonight. Now, the first step is to install Android Studio, and so while I'm up here gabbing away, anybody who hasn't installed it already, what you need to do is you need to open up a Project 5 assignment, which we talked about last week, and in here, there's a link off to the Android site. Oops, I'll open up in the same thing. This talks about downloading Android Studio. So Android Studio is customization of IntelliJ that adds a whole bunch of nice tools that makes it really easy to work with Android. And I think that's the right thing to use for this class. So it's big. It's a big IDE. It's got lots of stuff. So there's stuff to download there. So anyone who hasn't done that, please start that. Please be aware that everybody's sharing the same bandwidth. And so things might be slow. So those of you who are watching the debate in real time with your headphones on, sorry, it might be a little jerky, or maybe some of those old people are just having health problems. I don't know. So we will have that. And so then follow these instructions to make sure everything's working. And we'll pause for people to check in to make sure stuff as people are able to be successful. This is the tool set that you'll need to do your Project 5. And that's why I want people to come tonight, so that we can sort of lab it out and make sure that everybody is enabled to do Project 5, because just like getting you set up with Maven, just like getting you set up with the IntelliJ and things like that, I want to make sure that you're focusing on writing code and not trying to figure out your environment and working with tools. Okay? Awesome. So back to the slides. Okay. So we did a little bit of this last time. We talked about what Android is, there are various parts of it, who does it, the tools, what's in the activities. I think this is where we left off, application security. But just to set the stage. So you know, Android devices are really just little computers. They have an operating system. They have a network connection. They also have things that most computers don't. Well, they have things like cameras, which laptops do, or they have, but they also have things like motion sensors and and SD cards or stuff like that. But really, it's just a computer. And the thing I appreciate about Android is that it treats the device like a computer. It doesn't try to do anything special or fancy. So like all of the stuff that you're used to on a server class machine or your laptop or your PC or whatever is there in Android. And so it ought to be familiar with you as a computer science student. But there's some neat and useful stuff. Now, so it's it's built on Linux. Now, one of the really important things about device development, especially small device development, is security. Is the security of the device itself. And while mostly I'll talk about small handheld phone devices, Android is meant to really run on any device. Anything up to as big as really any device. There's a real operating system there. But it's used for set-top boxes. It's used for displays. It's used for, you can put in medical devices. It's in cars, right? It's an operating system, and it's got an environment. So there's real stuff there, and of course, security is very important. Security of course, there's your data moving in and out of the machine, but even the security of the device itself. And so Android, at all levels of its stack, offers protection. So at the very lowest level, there's the Linux kernel, which is Linux. We've all come to to know and love it. And this does things like provides your device drivers. It provides your power management. It is the thing that is closest to the hardware. And of course, that then is customized and optimized for the device on which it runs. Above that is something called HAL, unfortunate acronym for a computer thing, for hardware. Oh, I'm so glad you laughed. It's an old movie. Anyway, so the hardware abstraction layer. And so this is something that abstracts out, and deals with the device I/O. So this is your microphone, your camera, that provides an abstraction over that. Then you've got the Android native libraries. So all of the things that handle audio encoding and other media, movies, streaming, all that kind of stuff. Those are your graphics, low-level services like SSL, and then the Android runtime itself sort of lives at that layer. That is like the virtual machine, the JVM, if you will, that runs your Android application. And then on that, I've got spelling mistakes all over the place. You have what are called the Android frameworks. So this is like the Java libraries, if you will, that run inside your run on Android. And so this is all of the stuff like the windowing system, the view system, and all of a lot of the services and stuff that Android works with are all at this framework level. And finally, at the very top is your application code. And there are levels of security in between all of these things that are enforced through. Again, the kernel all the way up. There's a different level of security so that you can, so that your application can provide, and then the operating system can provide different levels of trust. So anyway, that's for those of you who like system diagrams. That's the way it works. Now, the kernel itself provides isolation through several means. There's user-based permission. So actually, one of the interesting things, or at least I found it was interesting, the way that Android applications work is that every application runs as its own user. So just the same way, all of you have user accounts on the CS Department Linux machines, right? And so there are hundreds of you with all different accounts, and the operating system itself knows how to protect users from one another and share information between users. Those same concepts are used in Android in the kernel. So then you basically use the same stuff that you get with Linux for doing user-based permissions, for doing process isolation. So you can have one process mess with the memory of another process. Also provides secure inter-process communication. Right, all that stuff that they've been developing for 50 years is now available on your phone. And so then, so each application is sandboxed into its own process, runs as its own user, and then the runtime runs within that. So there's protection there. Now, you've heard of rooting devices. This is basically giving your application or an application root access. And there are many devices that allow it. You probably don't want to do it. You might need to do it to debug it if you're running something really, really low level, close to the hardware. If you need to get into the kernel, most of the time you don't. And then there are other things related to security that the device itself might support, like an encrypted file system, so that if it's stolen or the government gets it, they can't find out who you've been texting. In theory. Now, this bubbles up the stack, and one of the places that you'll see it used is in the application permissions model. So, you've all experienced it in either your own devices or in also most software applications, is that when you either install an application or when you're using an application, it asks, the system prompts you, like for instance, you go to run, Google Hangouts in your browser for the first time. And it's like, hey, Google Hangouts wants to use your camera. Is this okay? Well, there's an equivalent thing with Android, in that when you, let's see, either install or when you run it for the first time, I can't remember which it is, you're asked, it's like, oh, hey, this application wants to access your camera, use your contacts, use your your location, stuff like that. Do you allow it? And if you don't allow it, your program can't run, your application won't run. All this information is specified in something called the application's manifest. So the manifest is a big old XML file that provides information about the application, such as the permissions that it needs. So there are tons of built-in permissions that it has for accessing all this stuff, for performing certain operations, accessing the network, all this kind of stuff. And within that permissions framework, applications can also define their own permissions. Interesting enough, on Android, if an application asks to install some permissions, it's an all or nothing thing. So you can't say, oh, well, I want to use my microphone but not my camera. Nope, it's, you have to sort of give it all permissions. That probably just makes it easier. Because otherwise, it makes it confusing for the application developer, because then they have to handle all these permutations based on what permissions they were granted. And that just complicates everything. If you have an application that attempts to perform an operation that it didn't ask permission for, the application gets a runtime exception. I don't know if it crashes, but certainly it won't work right. It probably crashes. So anyway, permissions are important. Okay, a few slides back, we talked about the various application components. So this is things like activities, which is a focused task, basically a page, if you will, in your user interface. And so then this is what is displayed to the user and what the user interacts with. There are other components like services, which is something that runs in the background, either provides data or performs some actions. And then there's broadcast receivers that have to do with events, and then I guess the manifest itself. Really, we're just talking about mostly for here, our purposes, it's activities and services. So your application is made up of activities and services, and the activity is just one screen. Well, if you want to display another screen, how do you display that other screen? Or how do you go to a different activity? How do you start a background service? You use an object called intent. And actually, I'm kind of skipping ahead of myself here. I think I mentioned it last time, but Android code can be developed in Java, and so there's this whole huge API that is associated with that. And one of the very fundamental classes, is something called an intent. Now, an intent does exactly what it says. It expresses an intent to go do something else. So the intent has some information, like, which activity it's starting. Like, for instance, I want to go compose a new email, or hey, I want to display details about my appointment. Something like that is the activity that's starting. We can also use it for starting services and broadcasting messages. Now, intents are either explicit or implicit. An explicit intent says, oh, hey, listen, go show this screen next. You give it the exact name of the intent. Actually, it's a Java class. You give it the Java class for the intent that you want to display. And this is usually, we're going between pages in your app, if you will. That's when you use explicit intents. There's also something called an implicit intent. And this is when you want to perform some operation and you don't really know or care exactly which activity performs that operation. You just want to do something, like send an email, or give someone a phone call, or browse to a URL. So what you do with the implicit intent, you sort of say, hey, I want to perform this operation. Hey, Android, you go figure out which intent can satisfy it. Which activity or service can satisfy it. And so then, and you see this on your phone when you go to you click on a URL in their Twitter app, and it gives you a choice of do you want to launch it in Chrome browser or Firefox. The Twitter just says, hey, let's go view this URL. Twitter probably doesn't really care which browser you use, right? And so it gives you, the user, a choice to do that. So explicit intents and implicit intents. Okay. I'm going to talk about some API, and then we'll pause before we get into the pretty pictures. Oh, is that chart at all readable? Sorry, that's way too small. I wonder if I can fix that. No, not quickly. Okay. There's something called Okay. Sorry. Context. Okay. Another important fundamental class in the Android API is something called context. So the context, it represents the entire application in which things run. So an application consists of activities and services. The context object, which is available to those activities and to those services and other APIs, represents the entire application. And this gives you access to, application-wide information. So it's the thing that handles permission checking, so you can check for permissions. It'll start activities and services. And so context is sort of like the big thing. As it turns out, both the applications and services, activities and services descend from context. So they both have a context and are a context. A service is something that is long running, runs in the background, and it's meant to provide functionality that isn't user facing. So again, going off and computing things or downloading things from the web, or maybe interacting with a REST service, that's something a service would do. And again, an activity, as we said a couple times now, is that user-facing component, the thing that displays your user interface, interacts with the user, and then performs operations, either calculating stuff right there, or then using an intent to trigger another service or activity. And that's a hard to read diagram right there. I apologize. If you've got it there on your own machine, you can zoom in. A little bit more details about the intent class itself. So the intent, it says, okay, here's the type of component. So either here's a behavior that I want to fulfill with an implicit intent or an explicit intent that says, hey, go launch this service, go launch this component. What you can do is you can set the component name to indicate what it is that you're trying to do. So you can reference it by the class's name or the class or an instance or whatever. So go off and do this to make an explicit intent. If you have specified the category of component to invoke to launch, you use that with you can use that. You can set the category to constants like there's a category for voice that says, hey, I want to interact with the voice interaction system. There's tons of these things, and we can have another category for go play some music. Here again, that will go off, and either if there's only one option, the Android runtime will go off and find that. Otherwise, it might prompt the user to make a choice. I think I'm going to pause here and show you some of the documentation. So there's what's in the notes, and that's kind of just enough to get you started, or maybe get you confused, or maybe both. But let's see here. Do I have it up here? Here's the reference. Okay, so if you go to, and I'm sure if you do a Google search for, there we go, Android Platform APIs. So these APIs are all documented in something that looks a lot like JavaDoc. It may or may not be JavaDoc. It probably isn't JavaDoc under the covers. Knowing Google, they probably wrote their own thing. There are, well, different versions of the API that are supported on different devices and stuff. We're going to use the most recent one, which is 29. And then you can, I guess this doesn't have terribly good search, but now, just like JavaDoc, you can browse things. So for intent, actually, what was the package on that? Android context intent. Context, no content. Lots and lots of spelling mistakes. So now you can browse the intent class. It takes an oddly long amount of time to run, to load. And it's Java code, right? It looks a lot like JavaDoc. You can go off and it's like slow loading JavaDoc. And I don't mean to, I'm sort of like scrolling through here, there's a lot to read. But the documentation for Android is really good. As a matter of fact, what I recommend that you do is after you get your environment working, go off and spend some time, an hour or two, just browsing through the documentation, right? We have that getting started page where you downloaded everything, right? There's not a textbook for any of this. Instead, go read the online documentation to just start learning about the system. I'm going to be talking about a lot of things like activities and intents tonight. I don't expect that you're all going to understand it fully afterwards because I'm not explaining it very well. But instead, go off and then spend some time, doing some further research to sort of get your to understand, the big picture about Android. Anyway, and we'll look at more APIs as the night continues. So in addition to what you want to, in addition to like what activity or service you want to start, you can also pass some other information along with that, which is very, very important. So there's something called an action associated with an intent. There are a whole bunch of built-in actions that sort of abstract various kinds of operations that you can perform. Like, hey, I want to view some data, or I want to send some data to another application component. And then, depending on what your application, your activities are doing, you might have a custom action that's something very specific to yours. But try to use the standard ones as best you can. Also very important is the data property. So this says, hey, when I go to launch an intent, when I go to do something, here is a URI. So a URI is like a URL essentially that identifies, oh, here's a piece of data that I want you to act on. So I was like, go display information about this appointment in my appointment book. Or hey, go send an email to this user from my contacts, things like that. Because you're conveying data as part of your intent to take some action, you can specify the MIME type for that data, because maybe that this data here is an image, and so then you're I don't know, sending Snapchat. I don't share pictures online. You use some app that shares pictures with people, and you want to send it, send an image to that. You would say, oh great, hey, here's the URI that identifies it, and by the way, it's a JPEG, stuff like that. And then your intent can also have extra payload, or just key value pairs. This payload is then delivered to the recipient of that intent, the activity or the service that is started by that intent, and then they can take that information and then figure out how to act on it. Oops, it's also got some flags, which I don't have examples of. That's kind of lame. So you can go read more about that in the API documentation. I want to pause here. So has everybody gotten their Android Studio installed? See lots of nodding. Has anybody not? Anybody need some help? No? Okay, good. Okay. So let's talk about activities. Now, one more time, once more with feeling, an activity is a single screen user interface. So basically you're looking at your phone and it's one page, if you will. It's one screen. And this is how the user works with your application, right? This is the thing that you look at. This is the thing that you enter text into. This is the thing that you touch on your device. Now, remember when we saw servlets for the first time, and probably some of you were like, wait, this is a program? There's no main method. How does this work? Well, remember in your servlets how you had your do get and your do post, and it was the web container that ended up calling those methods? Similarly, for Android, what you do is you define this activity, and your application will have a main activity, a root activity, and this is that object that's created, and then the Android, then Android will interact with that activity appropriately. So again, it's not like you start with a main method. It's like, nope, I'm going to have some activities, and they're going to move. You're going to create these activity objects. They'll have a life cycle. We'll talk about it in a minute, and they interact with each other and they launch each other. Most applications will have multiple activities. Here again, you'll have multiple screens in your application, and you can also have depending on what intents you respond to, you can have applications. Sorry, you have activities that are invoked from other applications. Again, I want to send somebody an email. You don't want to You probably don't want to put all the email functionality in your application. Instead, you want to have some other application handle the email for you. I give an example of a chat here.
Would any other application be opened through its main activity, or?
Yep.
Okay.
It all depends on what. Application. So activities can register. What's the right word for it? Can broadcast. Can advertise that. Hey, listen, I can handle an image, and I can view an image. And so then when you when you do something that says, how I edit an image, right? So then when in another application you say, okay, great, I want to edit this image, it gives you a little pop-up saying, okay, hey, do you want to use this app, or that app to edit this? Oh, okay, I'll choose this one. And then that routes it to the activity. And so, and this is cool. So you have basically applications that are loosely coupled, and the way they communicate is through intents. So there is a class in the Android app package, which is the root class for all activities. There is a file called Android manifest. So let's go over here and we'll look at our manifest. Oops, that's not what I wanted. Oh, it's got the wrong key bindings. What do I do? Control O. How do I need to go back to the old man key bindings. Well, whatever. We'll look for.
You mean like up is up?
What?
You mean like up is up?
Well, no. I guess I've been using IntelliJ too long. At some point, they went to Control O for open instead of Control N, which makes sense for most people, but I learned it the old way, so I'm sure there's a way in the settings to do it. I'll do that later. So manifest. Yeah. So here's the Android manifest, and I'll make it bigger so that we can see it.
There's no presentation plugin?
Oh, I'll do that at break. Remind me of the break, and I'll see if I can install. Yeah, the presentation plugin is the thing that pops up at the bottom. It's like, you just typed, Alt F12, and that's what this thing does, right? That's super helpful. Yeah. Although I don't know any special Android key bindings, so then it might not be super helpful. But anyway. You're going to see a lot of XML in this class. So Android uses XML for a number of things, all of its configuration. Yeah, well, an Android application is basically the stuff that you would write is stuff is Java code and XML. So you're going to see a lot of XML. I wonder why this is all in yellow. Oh, app is not indexable by Google Search. Consider at least adding an action view. Interesting. Okay. So this is an XML file that describes the manifest. So it's got information about the application itself. Every application is a package. It's just like a Java package. It's a namespace that identifies your application. And then the application has all sorts of things. As a matter of fact, application, can I get to it from here? Probably not. No. The XML actually corresponds to the Java documentation. So if I can find application real quick. What package was application in again? It was in the Android app application. Android app. Class. An interface is a class. Oh, that's unfortunate. Application. So here in Android Studio, I've got allow backup. Oh, maybe no. Wait, did I spell it wrong? Backup. Ugh. Okay, well, or maybe not. Okay, so maybe it doesn't do what I think it does. Anyway, this contains configuration information about your entire application. So things like, hey, what icon do you want to show there on the home screen? And we'll see what all this like mip map stuff means later. Here is where we define the activity, the main activity, which is actually some Java code over here, which we'll look at. Let's make it all big so we can see it. And then this thing called intent filter, which I think maybe I'll get to in the slides in a moment. But anyway, so there is a configuration file. You probably, well, let's see here. Maybe when you define more activities, you'll need to add stuff here. But otherwise, this is created for you by Android Studio when you create that new application. So this gives you a good place to start. Okay, and again, it has information about the activity. The intent filters, this is the thing, okay, the intent filters is where you say, hey, here are the intents that I support. So here again, so when we want to, it supports the main action, and that it also, and let's see here, and anything that's in launcher, which means that, yes, this thing can be launched from the home screen, and that, I forget what main means exactly. We can go look it up. Right, and here's where you can say, hey, my application can do things like, search the web, or yes, hey, I can, receive a certain kind of data. And also, we don't have an example of it there. This is also where you declare the permissions. So let's see here. Can I add something here? So maybe application permission? No. Is it in the manifest? Oh wait, permission. So you can have like a uses permission. And so here's all of the, like access Wi-Fi, or add voicemail, or answer phone, right? But this is like pretty cool, right? I mean, the Android platform provides all of this stuff. And so then here again, the platform is really rich. You can do all sorts of really cool things, which maybe shouldn't be surprising, but this is how you do it. And I think we're all familiar with what our devices can do, but what we probably don't know, or at least I don't know, is how it goes about doing it, how the designers of this API chose to model and expose all of this information. So anyway, so this is a lot of neat stuff to explore. So the Android manifest provides information like that. Okay. Yeah. Question?
No.
Okay. That's all right. Okay. And activities have life cycles. So the activity is the main thing that the user interacts with, and activities take up resources. So remember, most of the time Android is running on small devices, and small devices have constraints. Yes, there are the physical constraints, like you've only got so much screen real estate, but there are other constraints having to do with power consumption and network bandwidth and just CPU consumption, right? So a big part of what in order to have powerful applications that run on these not necessarily very powerful devices, the operating system, the runtime, exerts more control over your app than you're used to on your machine, that we're used to on your desktop or on a server. And so you as the application developer have limited control over certain things. So for instance, if the Android operating system determines that wow, your application's been running, no one's been interacting with it for a while, I need some memory, it'll kill your application. Right? That doesn't happen on your laptop. What happens on your laptop? Everything runs slower, and your fan starts heating up because there's lots of CPUs being used, right? And you know what? That might be appropriate for something that is plugged into the wall. Well, you don't want to run down your battery. We're out in the middle of the desert. So instead, the design choice that the people that came up with Android chose is like, well, no, as your application could be killed at any time. And we'll talk about sort of some of the things like that. So as a result, activities have this life cycle. And as the activity moves through its life cycle, the Android operating system informs the activity of when it goes through a change. And the way it informs it is by invoking one of its on methods. So actually, I've got the API doc right here. This is an application I want activity. Where'd it go? Can I get there easily? I cannot. Let me find activity. Do I have it still here in my browser? Oh, I don't. I have, okay. There's really no quick way to say activity. Is it activity manager? Oh, good it is. Yay. Same package. Thank you. Activity has, well, there's some documentation about like on create and on pause and stuff, but let's just look for on create.
That's the one that our little mini app.
Yep. Oh, actually, here's a nice little example of what you should do. So it has a bunch of methods, all of which are invoked at different times during its life cycle. And then your application can react to that. So for instance, it's like Android's telling you, it's like, I'm shutting you down. And it's like, okay, I'm shutting you down. You're like, oh, okay, I will write my persistent data off to disk. Or it's like, hey, you're starting up again. It's like, oh, okay, I'll go load my stuff from disk. And there is a file system on your phone, right? I mean, there is disk there. So anyway, so let's talk about the lifecycle a little bit more. So sometimes, now I've been giving these examples of the Android operating system, killing your app or starting your app or whatever. But other times, it's the user that does something with your application, right? You press the little, the stop button to go back to the home screen, or the home screen button to go back to the home screen, and your application goes away. And you might want to respond to that by saying like, oh, I'm like showing a video or I'm doing some animation or something. Stop the animation, right? I don't want to use the CPU to do that animation if I'm running in the background, if I'm not on screen. So you can respond to it that way. Other times, the lifecycle transitions are triggered by the operating system. Certainly when it starts your application, but also when it's looking to free up some resources or things like that. Now, it's important to handle these lifecycle events to make sure that your application behaves well, right? You don't want to you don't want your application to do something weird, like when the user says, "Oh, go show this other app, launch this other app," or whatever. Or maybe a text message comes in and now you get a little alert or something. Again, your application. This is something that's a little different from like working on the desktop. Your application really isn't the center of the universe. We sort of developing for the desktop. The whole idea was it's like, well, no, there might be other stuff running, but I'm really concentrated on my application, and I'm completely isolated and can pretty much ignore other stuff that's happening. It's different on Android. It's different on these small devices where you have a whole bunch of apps that are there and they work with each other. They talk to each other. They communicate much more than your desktop apps. And the reason is that here again is the constraints of the small device. You basically have your application that does one thing and one thing well, because we all know large, huge phone apps suck. They go a long time to download, long time to update. They take up too many resources. So kind of the design philosophy is that you want to have sort of small, compact applications, and this is why sometimes you end up with weird things like that's a good example of normally you just go to one website and get all this information. You have to download 3 different apps to have this part of the system, that part of the system, and something else. Those are often purposeful designs because that's what the operating system wants. That's what the platform wants. So again, during the lifecycle events, you want to make sure your application is well behaved. You want to save the current state someplace, and you want to make sure that you are a good citizen of the on the device, and that you're not consuming system resources when you're not using them, or we're not using them for something valuable. Now, you're working with your application, and let's say you're in the middle of something, right? Oh, you're browsing something, or maybe you're inputting some data, and oh look, a text message comes in, and then you go to a different app. The user goes to a different app. Your app, in order for it to be well behaved, needs to persist what it was doing. And there is a class called bundle, which provides a little persistent store that is associated with your application. And so then, do I go into more details? Yeah, I'll go into more details later. But anyway, this bundle object has the ability to persist name-value pairs, so key-value pairs, using put and get methods for various types of data. So you can put bytes, you can put characters, integers, character sequences, which is a interface that string implements, all kinds of data. You can quickly write it out so that when your application starts back up again or is resumed, then you can read that stuff and display the same information. Have it look like your application was merely put off to the side when in actuality what might have happened, it might have been shut down and restarted. So bundle is all about that. Okay, now let's look at some of the callbacks itself. Again, if we go back to the API documentation, it's got this whole lifecycle: create, start, restart, etc., etc. Okay. Create is invoked by the runtime when an activity is first instantiated. So usually it's like, oh, I click on the home screen, on create. Okay, all of a sudden my now my application is starting. Actually, now my activity is starting. What is it going to do? One of the things that all activities do is they initialize their user interface, right? Activities have a UI associated with them. The widgets that the user will see and interact with. You do that by by calling set content view on the activity, and then you give it some widgets to display. We'll talk about widgets after the break, but it all goes in there, and it's all set with that set content view. OnCreate is provided with a bundle. So a bundle is this class that's used to persist some application information that contains the activity's saved state. So like the last time we were using it, oh, you want to bring it back? Great, here's your bundle. And from that bundle, then you can go get that data. If there wasn't any saved state, maybe it's the first time it was run, or maybe the data gets cleaned up after a while, I'm really not that sure, you'll be provided a null bundle, and so there's nothing to initialized. Later on, there's an onsaved state, instance state method that is invoked in different parts of its lifecycle that is used to persist the application state. Actually, maybe we could just try that out right now. Anyway, let's see if it works. The activities state is loaded on restore instance state. Again, during different parts of its lifecycle. On create is just past the bundle because it's a chance to initialize it. Let's see what happens. Let's go write some code. So okay, so I created my first Android application, and it created something called main activity. And here's what it looks like. So it overrides the onCreate method. And the first thing it does is it takes that bundle, which is the saved state, and calls the super onCreate. It's actually very important that you perform this step, because what that does is that initializes other stuff inherited from the superclass. In this case, it's its app compat activity, which itself is I guess you really don't see it, fragment activity, blah, blah, blah. Itself is an activity. And there's lots of classes, right? So, if you thought the servlet API had a lot of classes, that's nothing compared to this. And that's the way that these things tend to work. All of the user interface frameworks that I've encountered have a very rich and very deep and rather complex class hierarchy for representing things, and we'll definitely see that when it comes to widgets, when it comes to representing things that the user sees and interacts with. Classes are a good way to model all of that because there's lots of behavior and lots of state, lots of properties that are inherited from other kinds of widgets. So anyway, we've got your activity, and when onCreate is called, we get this. So here's what I'm going to do. I'm going to launch the emulator, and I'm going to do it in debug mode. So this is like super awesome. You can run your application under the debugger. So here it is launching the emulator. Okay, so relaunch the emulator. And it's telling you, oh, hey, waiting for the debugger, and poof, I'm in the debugger. So now I can just use the debugger to go next. And then you can go back and you can see, oh, what is it doing? It's now on create. That's not really what I wanted to do. Let's step up. Oh, I clicked step in. And the next thing it's going to do, so right now it's still initializing. There's nothing to be seen here. And the first thing that it does, it says, hey, set content view, which is set the UI, right, the content that's being viewed, to this thing called r.layout.main activity main. And this is actually a reference off to the, well, if we click here, what does it do? Okay, it brings me off to this thing that we'll talk more about in a moment. Oops, how do I get that back? That might have not been smart. A preview over here, good.
Did you step into the?
I stepped into to the super dot, and that's why I went to that weird place.
Okay. But did you step into that content view?
I did, and then I stepped out of it.
Okay.
It's like, yeah. And then this is an XML representation of the UI that I'm about to populate in my activity, and this is going to be the second half of class talking about this. So anyway, so back to my main activity. Right now I've got nothing in my emulator. I'm going to step over this. I'm done with the method, and I guess it'll probably once I continue on here. Now it displays hello world. So that is my application. So this is what happens when on create. So here again, on create is a very simple on create. What it does is let's close the emulator. What it does is it populates the UI. Now let's see if we can use that saved state instance. So here's what I'm going to do. What am I going to do? I want to skip ahead here. Oh, let's see here. Actually, this contains my activity contains a text view. So I'm going to get ahead of myself a little bit. Text view, text equals get text. That doesn't sound right. No, it's a character sequence. Get view. Shoot, I can't remember the name of the method now. Calling activity, get class letter, get drawable, get view. Nope. Sorry, I'm not that familiar with the API, I guess. Activity. What returns the view? R dot. Sorry, I'm just going to go back to the activities. Oops. R dot. UI event. Here we go. Find view by ID. That was the method I was looking for. Find view by ID. And R dot ID. Oh, I don't have an ID for that, do I? Dot. I think I need to add. Oops. I need to add something to my main. Yeah, I don't have an ID here. I don't know why it doesn't do that by default. Equals plus ID.
The text view of your main.
I clicked on the activity main right here. Yep, and that knows to take it to the activity main XML.
Yeah, I'm on the activity main XML, but it's giving me like the visual interface for like moving buttons around.
Oh, go down here, design versus text. So this is design, and this is text.
Nice.
And so now I say dot text.
What did you add to your text view? Sorry.
That's okay. Text. I added this. I gave it an ID, and I'll get to this in a little bit. I gave it an ID property, and I said plus ID / text. So I'll explain what that means in a little bit. And so then, sorry, I'm going back and forth here. So there. And now I will say text.set text to, I'm going to say text.getText plus 5. I'm just going to run this again to make sure that it works the way I think it does. It kills the app and restarts it, I'm pretty sure. Here it is again. Hello 5, world 5. Awesome. Okay, now what I'm going to do is I'm going to say the following. So I'm going to say, I'll put this into a variable, and I'm just going to call it count. I'm going to start with 0. I'm going to do that, and then I'm going to say if saved instance state not equal null, I'm going to say count equals, actually I need to say this first. Count, and then I'm going to say if we have an instance state that comes in and it's not null, then count equals saved instance state dot get int count plus 1. Otherwise, count equals 0. So basically what I've done here, I'm figuring out how to use this bundle thing, right? And actually, let me just make this huge so you can see the whole thing. I'm saying, okay, hey, I'm going to set my content view to that. I'm going to go get a hold of my text view widget. So this is the text view, and we'll see this all in a few minutes. This is an object that represents my label there on the screen. So I call it text view. And then I'm going to say, I'll just put that, well, no. I'm going to say, okay, I want to add this count thing to it. So I'm going to say, hey, listen, go get something from my bundle. If my bundle, and I'm going to ask my bundle for the value int. Sorry, I'm going to, actually get int. This thing returns 0? I guess it must return 0 if it doesn't exist. Stop. Fine. Actually, we don't download. Not about boo. Okay, fine. Let me see if I can find that real quick. Bundle. Sorry, where did my API go? API, look for bundle. There we go. Oh. Bundle. Oh my gosh. Hello, go to bundle. There it is. Get int. Oh, it's inherited from something? How come I don't? Inherited constants, fields, public constructors.
You have to like tell it where, like, yeah, it's like, it tells it like.
Base bundle, there we go. Inherited methods from base bundle, get int. Oh, there's a default value. Okay, because or return 0 if no mapping or desired type exists for the given key. Okay, good. So I can do this. So then I'll say, okay, hey, listen, if it's already there, so go look up this value of this string associated with the string count and increment by 1. Otherwise, we're starting there. Where it's the first time it's been launched. Start it over and then print out. You know, can concatenate text display with set text. Use resource string and placeholders. Yeah. Maybe in my next version. So let's debug this and see what happens. And not run into it. So now what I'm demonstrating is what this bundle gives you. So I'm launching it again. It's going to restart the application. So it launches the emulator. The emulator says the application is still running. It recompiles the app, rebuilds the application, restarts it. Okay. So here I am. I'm going to create my onCreate, do all that. I'm going to get my text object. Now look, I mean, text is, and sorry this isn't bigger. I'll have to get all this stuff involved. Get this stuff out of here. Text is something called a text view, and you can inspect it here in the debugger. All sorts of stuff, which who knows what the hell it means. But that's fine. Saved instance state is null, though, so that's good to know. So I will, oops, okay, that's null, yes. So I'll skip over that. My count is initially 1. Set text will be to 0. Actually, it probably hasn't taken effect yet. Nope. And I will continue. Okay. Hello world is 1. Okay, let's go to the, let's go back here. Oops, sorry, click on this to go to the home screen. And now let's bring it back. It's that. Okay, so now I'm going to, oops, how do I stop it? There it is. Okay. How do I launch it again?
Maybe you gotta like toss it,
Yeah, does that work? Oops.
and then
Yeah, okay. But how do I relaunch it again? It's not showing up on the home screen, is it?
oh wait, back there. It's in the app menu,
What's the app name?
but it still says 0. Swipe up. Yeah, click and drag up on
Oh, here we go.
It's there.
Oops.
You gotta get it all the way up.
Is that this thing?
No.
That's the store. Oh, okay. It's not. That's not.
Where the circle button?
No. Okay.
Click and just drag up real hard. Yeah. There you go.
Yeah.
All the way up. Yeah, click that. First thing you
This thing right here.
go up.
Oh, it's still 0. Interesting. But the debugger didn't get it. Oh, interesting. So it didn't stop in the debugger like I had hoped. So how do I get it? Let's see. There's no back, right? Because there's no back. Oh, so much for that. So, oh, I know. What if I power off the device?
Oh, the power button.
Maybe. Oh, or what if I rotate it? Oops, that's probably not what I wanted.
Usually you turn it in 360 degrees and then the left side.
So wait, no, if I go back to the app again, it's that. Now if I do this,
No, still 0.
still 0. Oh, you're getting ahead of me. Gee whiz. I should type fast so you can't type that fast. Let's see here. What else can I do?
Bundles you can save on that.
Well, it should. Oh, you know what? Maybe it's because I haven't like overridden that. I should listen to my own slides. Right? What do the slides say to do? The slides say to override on save instance state and on restore instance state. So maybe that's what I need to do. Let's figure it out. So if you haven't figured out, I really don't know what I'm doing tonight. So I'm learning just like you.
So maybe you could put
On save interest. Oh wait, it's
You
not
have to
override
start.
anymore. How do I? Sorry, wait a second. How do I override? It used to be Command O. Code. Oh yeah, override method. Oh, Control O in this thing. Yep. On saved. On save.
No, it doesn't work.
On save instance state. Do I need to show method to implement, show classes, expand all? Well, where's the on save instance state? There it is. Okay, so save that, and then that's interesting. But then it was on restore, save instance state. There are two variations there. Well, let's just do that one, and then I'll set breakpoints there, and maybe I'll get those called. Let's see here. Is this guy still there? So if I go and kill it, yeah, I could kill you too. And then if I go and swipe up, oops, stop. Ooh, what am I doing? There we go. Well, it's not getting anything now. So I wonder if it's lost connection to debugger, probably because I killed it or something. Oh, so this doesn't work so well. Interesting. Okay, well, I'll try debugging it again and see if we can learn some more.
What's the difference between on create and on start?
I'll get to that in a moment. Actually, and this was on create that I'm doing, right? Yeah. That's why. Maybe I should be doing this on start. We shall see. Okay. Ooh, look at all that. It's like doing all sorts of things here. That's kind of cool.
But it's only on create that takes the bundle.
Yeah, so I'm probably doing this in the wrong callback. So this probably doesn't, because your activity is only created once, and then it's restarted again, or something, unless, yeah.
Once under what, like Phone and Steve
I'm not sure.
for Power Up.
Well, it's when the activity is launched, right? And so then, yeah.
Even if you like exit the app and then go back into it, it's still only created once.
Yeah, and since I lost the debugger connection, it's kind of hard for me to tell. And here, okay, and so then if I go and I go back home, nope, I didn't get a call back there. And now if I go and I go back, okay, so I don't know at what point are these called. Interesting. Okay, well, we'll leave it in the debugger and we'll find out. So let's talk about more things in its life cycle. On start. So this should be on after create, I think is what it is, yes. So now on start is called when right after it's created. That should be on create and not on start. Or when it's been stopped and restarted. And so then on start is all about not so much initialization, but as starting things. So it's like, oh, you got some animations, go start drawing them. Or if there's other visual elements that really aren't loaded as part of your UI, maybe you've got an image or something that loads, then on start would do that too. And here again, just like on create, you need to call super.onStart in order to make sure everything's initialized correctly. And so the whole idea is that onStart isn't meant to perform too many operations. It's a pretty quick thing. It's like, oh, hey, I just sort of get everything running. If anything is long running, onStart should kick it off in the background and then respond to the activity when it's done. Now let's try it. Let's play with onStart and see what we can get. So this is probably what I want. Oh man, you were just like too late.
No, games are good.
Nice. Which little menu? Oh, I'm clicking debug. So I'm clicking debug up here to run the debugger. Oh, sorry. How am I, guys? What was that handle? Okay. Was it the Control O to override it? Sorry, yeah, the menu, yeah. So for overriding a method, I used code override methods, which is Control O with these key bindings. And so that gives you, so that is overrode on start. So let's see what on start, let's see when it is invoked. Let's see here, did I rerun the debugger? Oops, I might still be attached. So I'll run this again. Has everybody gotten to a point where they can launch the app under the debugger? Yep. Okay, this is your chance. So don't be bashful. We'll take a break in a moment. I said that several moments ago. So on create. Oh, look, here's on start. That's neat. Okay, so now it's been started. Oops. So let's see here. If I then go back to the home screen, and then I bring it back, is it restarted? It is! Hey! This is a little bit more interesting now. Okay, this is what I was hoping for. So now, let's see if we can use the bundle. But how does one get the bundle at this point? So maybe I don't understand. Oh, no, I can get the bundle from the context, I think. Get context, get application context, get bundle. Shoot, how do I get the bundle? Do I get the bundle from, is there a get bundle method? How do I? Android get bundle on start. Okay, Stack Overflow. So you can do this when you're an adult. That's right. Get intent, get extras, on start. Oh, get intent, get what? Really? That ain't right. That's from the intent. I don't want it. I want the application bundle. I don't want the intent bundle. Interesting. So yeah, I guess I'm confused on how you're supposed to use that. Well, I can go off and let's see here. Outstate, save instance state. So these two, oh wait, these two are not valid anymore because I changed the, okay, so I wonder if not, oh, I wonder why those, I wonder why I can't debug there. Interesting. On save instance state. And then, actually, is there another on save instance state? Because I don't need that persistent thing. On save. Show classes, show methods to implement. Select methods to override.
Is there a change to
On-
1? Does that mean I've done it?
Yeah, you've done it. Yeah, you figured it out. How'd you do that?
This is dumb and shouldn't work, but like I copied the code into on start as you did, and then just put bundle saved instance state as like a parameter to that.
Uh-huh.
And
Oh, you called on save instance state.
Yeah,
Oh, that's how you use it. Oh no.
I guess.
Okay. I like that. Oh, glad you guys know what's going on. Okay, so let's see here. Okay, so otherwise this, otherwise kind of equals 0. So I set this, and then I say bundle. Oops, saved instance state dot set int set put int probably, yeah, put int count, the count variable, and oh well, that's actually, maybe this just would have,
Oh yeah.
yeah, I never set it to an interesting value. Oopsie.
Oh.
Maybe that might have been a good idea. Ay. Put in, what isn't it? It doesn't like this. Why is it saying it's yellow? It's returning void. I don't know what's complaining about. Okay, I wonder what this does now. Look at this science, right? We're all learning together because I didn't take the time to learn it beforehand. It's good.
I'm getting a problem with recognizing key, like line 20.
Like line 20. This key right here. So like there's another get int. Let's see here. This is, it's got either one parameter or two.
Like as much as I can see, this is the same thing.
Did you apply the changes to activity main XML?
You probably wouldn't complain about that. So you're calling saved instance state.getInt,
Yeah.
and it's saying it doesn't like the key. If you do a command open apple p, what does it tell you it has for parameters?
String key.
Well, it should be okay then. And you have a string constant there for the key?
Yeah, that's the same.
Word.
Steph.
Yeah.
I don't know. Maybe work it out over break. Maybe I should get you on a Google Hangout. I don't know. It's almost time for a break anyway. Okay, so wait a second. So now I actually saved something in the saved instance state. Oh, and then here I need to, actually, no, I need to do this regardless of what the value is. I should do it here. So what happens, if I do this now? Am I running the emulator? I am. I'm going to stop that.
And you're in on start.
I am on start, which,
And
you
you're
know
not,
what?
But you're not overwriting it so that you can pass it in the bundle
Yeah.
savings system.
So,
It has to be another way because it still doesn't really work.
Well, but remember, once I killed the application, it didn't hit it in the debugger again. So there was a bug here in which I never saved my state, right? Dumb. So maybe this will work now. So now, I've got, oops, first Android keeps stopping. What is that? Hey, wait, what's going on there? Did it crash? Oh. So it's crashing now. So I wonder why. What did I do to break it? So is this called a save instance? I should probably figure out how to look at. Actually, is there console? Oh, look at that! Attempt to invoke virtual method put int on a null object reference. Well, that would do it. Okay. Oh, so how do I get a new one, I wonder? So wait, who got it working?
Gabe's number was incrementing to 1 when he would flip it sideways,
Yeah,
and
it's still good.
then just does an increment after that.
It just goes to 1.
My
Just
code
goes
is
to 1.
identical to his. Mine doesn't increment, and it also doesn't crash with the put in.
Interesting. Well, I got put in because I got a null pointer exception. That makes sense. So then, did you override the on save? Oops. On the let's see here. How do I?
I just initialize count to 0 instead of keeping it uninitialized.
Well, but the first time it loads, the bundle is null. So I wonder how do I? So you call save the bundle?
I don't think that was doing it.
Okay.
I just got rid of all that and it still just goes to 1. All I have right now is just an empty on start that overrides the other on start.
Interesting. Okay, so then
But on create is the same as you had it, so I don't know what's
so I guess I should put it here. And then right, because it's like, hey, if it's not null, get the old value, put in 1. And yeah. So okay, so let's see what happens here. That was pretty neat though when it crashed, right? I mean, you can just go and look and see get the null pointer exception. That was nice of it. Sure, the debugger doesn't seem to be any slower. Loading up, waiting for debugger, doing its thing. Let's see here. Just walk through it. It is null.
When you change something in activity, what's the proper way to restart the file and get the new?
I just close the emulator and redeploy and just run the. So I'm calling on start. Okay, and so now it's 0. So yeah, what happens when I change it? No, nothing there. Okay. And now if I close it, if I open up another app, and then I go back, on start is called. Okay, well I obviously need to figure out how all this works. But I'm having fun. You're probably not. Although, I mean, the intent here is that you play along too. And so, I mean, I like what's going on here, right? You know, people are trying stuff. We're all trying to figure it out together.
It just seems weird to me that like identical code can read different behavior.
Well, it might not be as identical as we thought. Or maybe there are things. I don't know.
Something's gotta be okay.
Nope, still 0. Okay. Well, maybe I'll read up on that over the break. Okay. Yeah, it seems like it should be start that. Yeah, I wonder. Sorry, one more thing. So then I wonder if. Well, I did, but all I did was call super, so it didn't really do anything. So I wonder if it's supposed to be. Okay. Android save data in activity bundle. Save and restore activity. Do we have like a decent one? Code Expedia. I'm just hoping there are any like inappropriate ads. Okay. Yeah, on save. Oh, okay, wait a second. So, oh, I see. Okay. Oh, okay. So you are supposed to override on save state. Okay. And then on create, this is where that, what? That's weird. Okay, retrieve it in on create, and then also on restore instance state. Okay. Okay, we'll give this a try then. Sorry. Once more with feeling. So I think this is okay. So now I need to override on save. Why doesn't it default to having everything open? That is, IntelliJ doesn't do that. On save instance state. And so here's where we need to save it. So we call super on save instance state last. Okay, outstate. And so then we say outstate dot put int count. And I'm going to put count now. I'm going to make count an instance field. Create field count in main activity. So now I've got it up here, and I'm going to say this dot count. And then every time I start, I'm going to increment count. So I guess no. So I'm going to I'm not going to do the increment here, and I don't need to do this. I'm just going to get the save instance, otherwise count as 0. Then I'm going to increment count down here in on start. So every time it starts, it's going to increment it. I'm going to save it there, and then I'm going to override on restore instance state, and I think I'm just going to get the bundle. And first thing I need to do is probably call that first on start.
Why are you declaring outstate?
Oh.
Outstate's
It's passed in.
Oh, bundle outstate.
Yep. Let's see here. It says if save instance state equals null return. Okay, so you call super, and then you say if saved instance state not equal null, then saved instance state, which is a very long name. I'll get int and then count this dot count equals that, maybe. Okay, internet, we'll see. This is anyway. Okay, let's try it once more. And let's set some breakpoints just to see what we can see. Okay, so here we are on create. Here we are on start, and it increments count. Okay, so the count field we believe to be 1. It started with 0, but whatever.
Was one of the problems maybe the count wasn't a global variable?
Well, I thought it would be global because I saved it away in the saved instance state, but we never got a non-null save instance state, so I'm really not too sure what all that means. So now if I go and I stop the app, oh ho! Look, now it's saying on save instance state. Okay, and the count is 1, so we'll save that there. We'll save that. We'll continue going on. Okay, now let's bring it back. Aha! On start is called. Oh, interesting. On start is called. Okay. Oh, you know what? I'm doing the wrong thing. It is what I expected, actually, but I realized that my logic is wrong here. I shouldn't be. Yeah. So I'm incrementing count, and so now count is 2. But you know what I never do? I never.
Put it in your text.
Yeah. Oh, and on restored was never called. Oh, interesting. So on restore was never called. It is there. Yeah, I never said it in my text. So really, what I should do then is what I should increment it here. This dot count. I'll increment it here. And then here, I'll go, and this is probably where I want to, and here's what I'm going to do. I'm going to, let's see here, I'm going to put this here, and now I do this, and I'm going to put this into a method called, I'm going to extract a method, I'm going to call it display count. And now here on start, I'm going to say display count. Interesting. Okay, well, let's see what happens now. Okay, so I'm creating it. Call on start. On start displays count. This is kind of what I want. Let's step into there. Gets that, and count is 0. Okay, and so then it displays hello world 0, 0. Is that what I expected? Ooh, why is it 0, 0? Oh, because each time I append it. That's kind of dumb, actually. Okay. It shouldn't be this. It should be just hello. But whatever. But let's just see what happens. Okay, so now I stop it. It saves the instance state. I start it again. What is the instance state? The instance state display count. Count is 1. Okay, now it's got 1, and so then I stop it again. It saves the instance data. At first incremented it, 2. I restart it again. It displays the count. The count's got 2. Okay, so we're figuring this out together. Yeah. And so then, okay, so the way it works is that, okay, so on start, here's where you want to populate your UI. Here's where you want to populate the state of your UI. So on start is where, like, here's where I throw up all my components, throw up all my widgets, and then I put the information in those widgets on start. Okay, that's like when your application comes back, that's when you populate everything. Wow. Computers, neat. So so I'm trying to figure out when restore instance state is called. So what happens? What happens if I kill the application? I'm tired of all this debugging. Now if I kill the app, and now if I start it again, oops, I start it again, what state will it be in? 0. Okay, well, I still understand that part of it. Neat. Okay, I think it's time for a break. I've been talking for like an hour and a half. So let's take 10, and we'll come back and learn some more. Super neat.